the given point is 2, 4. Okay. Now suppose let HK be the point on the curve x square is equal to 8y, which is nearest to 2, 4. Okay, suppose this is your given curve. See, the curve looks something like this. The curve looks something like this. Okay, and this is your origin, and 2, 4 is your point this way. Okay, you need to find a point on the curve which is nearest to this point. You understood the question?
Yes, sir.
Okay, so you need to find this point. Say I call this point PHK. Okay, so this is your point PHK. Okay, let PHK be a point on this curve which is nearest to the point 2, 4. So therefore, since HK lies on the curve, it must satisfy the equation of the curve. Therefore, H square is equal to 8K. Then this point is a point on the curve. It must satisfy the equation of the curve. So in this equation, if you put x is equal to h and y is equal to k, that must satisfy. Call this equation number 1. Now see, what is the distance between these 2 points here? Let us call this point A. What is the distance AP? Suppose we call this distance D. Then what is this distance? Remember distance formula? Distance between 2
Yes, sir.
points is h minus 2 whole square plus k minus 4 whole square. Right? So now you simplify this a little. You get what? You get root over of
Yes, sir.
h square minus 4k plus 4 plus k square minus 8k plus 16. Okay, this is what you get. And now you just simplify this further. You get h square plus k square. This is 4h, not 4k. Okay. H square plus k square minus 4h.
Sir, can you hear me?
Yes. Plus 20.
Morning, sir.
Morning. So which is root over of. Now see, h square is equal to 8k, right? So you put h square is equal to 8k here plus k square minus 4h um, minus 4h minus 8k plus 20. Okay. So therefore, what do you get here? This 8k cancels. So you get root over of k square minus 4h plus 20. Okay. So now you have got two variables, h
Sir.
and k. Okay. Again, you remove h. Write everything in terms of k. remove h. How do you remove h? What is h? H is equal to 8k here, isn't it? So therefore, what can I write from here? H is equal to
Yes,
square
sir.
root of 8k. That means 2 root 2k I can write, right? So what you do here is you simply put h is equal to 4 2 root 2k, okay, and plus 20.
Amen.
So what do you get here? You get root over of k square minus 8 root 2k plus 20. This is what you are getting. Okay, the distance d. See that the distance d I want to minimize. This is actually an applied problem. Okay, the distance d I needed to minimize. That is, this is my minimizing function. Okay, and but I had two variables h and k here. Okay, so what I did was, with the help of a relation here, I made it everything in terms of k. Okay, so therefore, what do you get? D is equal to this. Therefore, d square will be equal to what? Root over of k square minus 8 root 2k, not square root, sorry, k square minus 8 root 2k plus 20. Right or wrong? Understand this very well.
Yes, sir.
Okay. As I told you, I repeat once again. This
Yes,
is
sir. Can,
this is my minimizing function. This is the function I want to minimize, because I want to minimize the distance between the 2 points. And with the help of what I am minimizing? With the help of this relation I am minimizing. Okay. When in the minimizing function, in this function, minimizing function, okay, I have two variables, h and k. So with the help of this relation between h and k, I make this into a relation, into a relation of containing only k. I make the minimizing function as a function involving only k. Because see, when can you differentiate? You can only differentiate when the function has one variable, right? With two variables, how
Yes,
will you
sir.
differentiate? So that is why with the help of this function, I have removed h from here. Now, once I remove h, I get this. Now, but the problem is here, there is a square root. So remember, if I am minimizing this d here, this d is equal to square root of this. That means it is the same as minimizing d square. See, if d square is minimum, then d will also be minimum, right or wrong?
Yes,
yes, sir.
sir.
If d square is minimum, then d will also be minimum, because d is positive. We're talking about the distance, right? So therefore, what we are going to do here is, we are going to call this d square, this d square, okay, let us call it by some other name. Let us call it a, say. Okay. Now we are going to minimize a. If we minimize a, then distance will all obviously be minimized. How do you minimize? For max, first differentiate dA dk. What is the variable here? K, right? So dA dk. What is dA dk? It is 2k. 8 root 2 is a constant, minus 8 root 2. Right? This is dA dk.
Yes, sir.
And what is d2a d2a
Yes, sir.
dk2? What is d2a dk2? It is 2, right?
Yes, sir.
So for
Yes,
maxima or
sir.
minima, for local maxima or minima, dA dk must be equal to 0. If dA dk is equal to 0, that means 2k minus 8 root 2 must be equal to 0. That means 2k is equal to 8 root 2. That means k is equal to what you are getting? 4 root 2. Right? Now at, what is for second derivative test, what do you have? At k is equal to 8 root 2, what is the value of d2a dk2? The value of d2a dk2 is 2, which is positive, right?
Yes.
2.
Therefore,
Yes, sir.
k is equal to 8 root 2 is a point of local,
Maxima.
minima,
Maximum.
minima,
Oh,
because
Maxima.
second derivative is
Minima.
positive. Okay, it's a point of local minima. And what is the corresponding value of h from this relation? We can get the value of h. What is h? H square is equal to 8k. Therefore, h square is equal to 8k is equal to 8 into 8 root 2, which is
8K.
64 root 2, right? Okay,
Yes, sir.
Yes, sir.
so h square is this. Now, you can write this as 2 to the power of 64 can be written as 2 to the power of 6, and root 2 can be written as 2 to the power of half. So this is 2 to the power of 6 plus half, right?
Yes, sir. 13 by
So the question here is actually wrong in the sense that the curve should be x square is equal to 4y. So you get h square is equal to 2k. So you are putting h is equal to 2k here. Okay. So you're getting here again the correction will be
Okay, sir.
8k.
maximum.
K square minus 8k. Okay. So this will become,
Sir,
yes.
sir, from the things which we have changed now,
Hmm.
from there you can you explain AP is equal to D is a distance formula. Distance
Hmm.
formula I have understood, but
Hmm.
the proceeding the approaches that
See, h square
I
is there. So I replace h square by 4k. This h
yes, sir.
square I replace by 4k. So there, oh, this should also be 4k. Okay, we need to change a lot actually. Okay, h square is equal to, let us start with a very simple problem, applied problems. Okay, the question here is a rectangle is given whose area is constant. Whose area is constant. Okay, prove that the sum of the length of its sides, prove that,
Sir, these are practical problems.
yes, applied problem. Prove that the sum of the length of its sides is least when it is a square. Remember, there are various when you are attempting these kind of problems, especially Amir, it goes out for you. You have to be very careful when you are attempting these applied
Okay, sir.
problems. Okay. Now there are certain decisions that you have to
Okay,
take in
sir.
stages. There are certain decisions that you have to take in stages. Understood? What decision you have to take in stages?
Yes, sir.
First is you will have to determine what is the step one. Your step one will be to determine the minimizing or the maximizing function. Remember in LPP we did
Yes, sir.
minimization and maximization. Similarly here you will first have
Yes,
to
sir.
identify the minimizing or the maximizing function. Okay. And what is the minimizing or the maximization function? See, the question is prove that the sum of the length of its side is least. Least means minimum. So that means sum of the lengths of the sides means perimeter. Okay, say sum of the length of the side is perimeter. So this is your perimeter is equal to minimizing function, right? Okay, so perimeter is your minimizing function. You have to minimize the perimeter. Sum of the length of the side means perimeter. So perimeter is the minimizing function. Now you will have to minimize this function with the help of what? Next is step 2. Step 2 is identification of the auxiliary relation. You know what is auxiliary relation? You know what is the meaning of auxiliary?
Sir, in complex number we did, no?
Auxiliary
And
auxiliary in English means helping. Okay, to help out, the subordinate. Okay, someone lower in
yes,
rank
sir.
which helps you out. So identification of auxiliary function. Now what is the auxiliary function? See, this rectangle whose area is constant. So my auxiliary function is area is equal to constant, right? This is my auxiliary function. With the
Yes,
help
sir.
of this function, okay, I am going to minimize this function. Understood? With the help
No,
of
Yes,
sir.
yes.
this, with the help of the auxiliary function, I am going to minimize or maximize my the function. Understood?
Yes, sir.
Govinda.
Yes, sir. Yes, sir.
So first you have to identify the minimizing or the maximizing function. In this context, our minimizing or maximizing function is the perimeter. With the help of what function? With the help of the auxiliary function, which you have to recognize. What is the auxiliary function? That area is constant. And the last step here is identification of variables and constants. Which one is a variable and which one is a constant? Okay, now see, perimeter here is what? Suppose I take the length as x and the breadth as y. What is the perimeter? Twice of x plus y,
Yes, sir.
right? So here,
Huh?
x and y are variables, right or wrong?
Yes, sir.
X and y are variables. Which one is a constant?
Sir, true.
Area is a constant. Area, A.
Uh,
Area, A is a constant, right? And what is the area here? Area is x into y, right?
Sir, from where we
Yes, sir.
get this area is constant.
It is given here, see? A rectangle whose area is constant.
Uh,
Okay?
yes, yes, yes.
So
Sir, whenever the area is constant, that means x, y.
whatever is given to you, whatever is given, suppose whatever is given, that will be constant. What you have to introduce, that will be a variable. What are you introducing here? You are introducing the length and y as the breadth. So these have to be your variables. Area is given to be constant, but what is your variable? You are introducing the length and the breadth, right? Isn't it? You
Yes,
are
sir.
introducing the length and the breadth, right?
Yes, sir, yes, sir.
Are the length and breadth given to you?
No, sir, length and breadth is not given.
You are introducing
No,
the
sir.
length and breadth. That means they must be constant. If you are introducing anything, that will be a variable, and whatever is given in the problem, that will be a constant. So area here is given to be constant. So x and y is a constant, right? This one. This is my auxiliary function,
Yes, sir.
auxiliary relation. Now what will the auxiliary relation do? With the help of the auxiliary relation, we are going to minimize the this function, right? This is what I said in your step 1 and step 2,
Yes, sir.
right?
Yes, sir.
This is what I told you in step 1 and step 2,
Yes, sir.
that with the
Yes,
help
sir.
of auxiliary relation, you will have to minimize or maximize the function. So with the help of this relation, a is equal
Yes,
to
sir.
xy, I am going to minimize or maximize this function. Okay. So what I'm going to do here is, since see, I have two variables here, x and y. So what will my auxiliary relation do is, I can remove one variable from the function. How? See, we can write y is equal to a by x, right? Isn't it? We can write.
Yes, sir. Yes, sir.
So therefore, now p will become what? P is equal to twice of x plus y. So now I from two variables, now I will come down to only one variable. See, have I come down to one variable or not?
Yes, sir.
Yes, sir.
Right? So here I
We
had two
interchange
x, and
in respect of
we
y.
had x and y here. But with the help of this relation, auxiliary
Yes, sir.
relation, we came down to one variable. Now this is very convenient to work. Now I can work.
Okay.
Okay. Now we can minimize or maximize very easily. Now what we do here is, we got p is equal to twice of this. Therefore, we now find dp dx. What is dp dx? Area, I remember here is constant. This is a constant. Okay. How will you differentiate this? 2 is a constant. You can take it out of the differentiation. You get ddx of x, right? Plus ddx of
Yes,
a
sir.
by x, right? Now next step, twice ddx of x is 1. And see, this is a constant. You can take it out of the differentiation. A ddx of 1 by x. Am I right or wrong?
Yes, sir.
Next, what I can do, I get twice of 1 minus
In
ddx of 1 by x is minus 1 by
x.
x square. So I get,
Yes, sir.
right? So that is why I told you that you must keep in mind which one is a constant and which one is a variable. Area here is constant. X and y were variables. With the help of auxiliary relation, from two variables, I came down to one variable only. Okay. So x here is a variable. A here is a constant. So what is the condition for maxima or minima? For local maxima or minima, dp dx must be equal to 0. That means twice of
Yes.
1 minus a by x square must be equal to 0. That means 1 minus a by x square must be equal to 0. That means x square must be equal to a. That means x must be equal to root a, positive square root, because x cannot, length, x is length cannot be negative. So we cannot take plus or minus a, we simply take plus a, plus root a. Okay. So x is equal to
Yes, sir.
root a is a point of local minima or maxima. Next, what we want to check is whether x is equal to root a is a point of local minima or maxima. So what we do is we differentiate again. What is d2p dx2? We differentiate this one. What do you get? Twice of 0. A is a constant. You can take it out of the differentiation. And what is the differentiation of minus 1, 1 by x square? It is minus 2 by x cube. Right? Right or wrong? This differentiation.
Yes, sir.
So what are we getting? We're getting 2. In fact, we are getting this 2a. This,
Minus
it is, we are getting plus
minus a
2a, plus
plus
4a, plus 4a by x cube.
4 x
Right? Now what is
cube.
what is
Okay.
my point here? X is equal to root a. So let's check. At x is equal to root a, what is the value of d2p dx2? Put it here, 4a by root a whole cube, right? Which is positive or negative? This one?
Sir, positive.
Positive, because area always is positive. So this is always positive. Therefore, what can we write? X is equal to root a is a point of local what? Minima.
Maximum.
Minima. Because second derivative is positive. Second derivative positive means minima. So therefore x is equal to root a is a point of local minima. Therefore at x is equal to root a, p is minimized. Right or wrong?
Yes,
Right?
sir.
But at x is equal to, and at x is equal to root a, what is the value of y? Y is equal to a by x, right? A by root
A
a,
by. Yes, sir.
which is root a, right? So what is my point here?
Yes, sir.
At x is equal to root a, y is equal to root a, p is minimum, right? P is minimum, and what is the minimum value?
Yes, sir.
What is the minimum value? What is the minimizing function? This one.
Minimizing function.
Put it in the minimizing
Yes,
function.
P is equal to 2
Is equal to
y.
twice of
Yes, sir.
x plus y. And what is x? Root a. And
Root a
what is y?
plus 2.
Which is 2 into 2 root a, which is 4 root a.
Yes, sir.
And what was my problem here? Prove that the sum of the lengths of its
That
side
is
is
given.
least when it is a square. That means sum of the what are we
Yes.
getting? P is equal to root a, right? That means sum of
Yes,
the
sir.
lengths of the side is
Yes,
this,
sir.
which is equal to 4 root a. That means we are getting P is equal to 4 root a, right?
Yes,
Prove
sir.
that the sum of the length of its side is least when it is a square. Yes. So therefore, um, perimeter should be, just hold on. You don't need to find the perimeter actually. Okay. You don't need to find out the perimeter. The question was prove that that rectangle is a square, right? You don't need to find all this. Minimizing minimum value, you don't need to find. See, at x is equal to root a, this is your length, root a. And what breadth are you getting? Root a.
Root a.
That means the rectangle must be a square. Therefore, it must be a square. Right? Length is equal to breadth. Therefore, it
Yes,
must be a
sir.
square.
Yes, sir.
Okay. So we stop here for today.